So let's go ahead and do a little review for the Unit 4 exam. So right here we have some gram to mole equations or some moles to gram equations. And let's remember that if we are going from grams to moles, that means we're going to start with grams as our given. So we need to cancel out with grams and end up with 1 mole on top so our answer can be in moles. And if we're going to go from moles to grams, it's going to be the opposite. We're going to start with moles on top. That means our 1 mole is going to go on bottom and grams are on top because we want to end with grams. So let's look at the first one. It says how many moles are in 12 grams of COH? So since it says 12 grams of COH, that's our given. So we're going to start with that in our first box, 12G of COH. And we want to know how many moles, so that means our answer is going to be in moles. So we need to end with the 1 mole on top. So we're going to go ahead and put grams of COH, and we know that grams is always equal to 1 mole of the substance. So now we have to figure out, using the periodic table, what the mass of 1 carbon, 1 oxygen, and 1 hydrogen will be. So on the table, we know that carbon is 12, oxygen is 16, and hydrogen is 1. And we're looking at the bottom number for the atomic mass. So if we add together 12, 16, and 1, that's going to add up to 29. So we're going to go ahead and put 29 in our box right here. So when we're doing our calculations, we're going to multiply the top numbers and divide by the bottom. So if we wanted to look at it in a simpler way, we would have 12 grams times 1 mole divided by 29 grams. So if we multiply the top and divide by the bottom, your grams will cancel grams. So you're left with 12 times 1 divided by 29. So if we do 12 times 1, we end up with 12 moles over 29. So if we divide now 12 divided by 29, our answer is going to be 0.413. So round that to the nearest 2 decimal places. So 0.41, because 3 doesn't make us round up. Now let's look at one where we're going to find the mass. So if we're looking at one to find the mass now, that is number 3. It's a little bit different. So for number 3 over here, it says, what is the mass of 3 moles of CO6? So our given here is the 3.5 moles of CO6. So in order to cancel moles, this is where we have to put 1 mole on bottom of CO6. So moles will cancel moles. And that 1 mole is equal to the mass on the periodic table. So we have 1 carbon and we have 6 oxygens, which is going to be 6 times 16. You could write out 16 6 times. That's just a lot of writing though. So 12 plus 6 times 16 is going to come out to 108. Just forgot the O on that one. 108. All right. So now we're going to multiply the top and divide by the bottom. So if we were to do that, we get 3.5 times 108 divided by 1. So if you put that in your calculator, you get 378 divided by 1. So our answer is going to be 378 grams of CO6. All right, let's try some more. So we have how many moles are in 1.4 grams of NaCO. So we're going to put our given, which is the number it gives us, 1.4 G NaCO. So we're going to put grams on bottom to cancel, and our 1 mole on top. So Na is 23, or 22.99, so it'll round up, plus carbon, plus oxygen. So our mass, if you add those numbers together, will come out to 51 grams. So we need to again multiply the top and divide by the bottom. So grams will cancel. So we'll do 1.4 times 1 divided by 51. So we're going to come out to 0.027. So if we were to round to the nearest 2 decimal places, this 7 is going to make us round up on the 2. So our final answer would be 0.03 moles of NaCO. All right, we got one more of our gram to mole here. So on the other side, it says, what is the mass of 8 moles of water? So we're trying to find mass again. So we're going to put our 8 moles here of H2O. To cancel that, we need to put our 1 mole on bottom. That's how we can convert from 1 mole to the grams. So this is our conversion factor. That's how we get from moles to grams or grams to moles. So we have 2 hydrogen plus 1 oxygen for our mass here. So we're going to have a mass of 18 grams of H2O. And we got to do our math now. So we're going to have 8 times 18 divided by 1. So that's going to come out to be 144, and we want to find the mass, which is grams, of H2O. So it's kind of a look at our grams to moles here. Let's look at a little bit of balancing real quick. So here we have the aluminum is replacing the copper to make aluminum chloride. So this is one thing replacing another. This is single replacement. So if we were to make our RAP chart for this one, you have your reactants, your atoms, and your products. So our atoms are aluminum, copper, and chlorine. So we have 1 aluminum on our reactants. We have 1 aluminum on our products. If there's no number next to it, that indicates a 1. We have 1 copper on our reactants, 1 copper on our products. So everything looks balanced so far. Then we have 2 chlorine on our reactants and 3 chlorine on our products. So that one's not equal. And we want to know, what can I multiply these chlorine by to get them to equal the same number? So what do 2 and 3 have in common? So if you multiply it by 1, it's just going to stay the same. If we were to multiply 3 by 2, that would give us 6. So 2 and 3 both go into 6. So that means I need to put a 2 here, which tells me I have 6 chlorine now on my product side, but it also goes to my aluminum. So I now also have 2 aluminum on my product side. And we'll get back to balancing that one after, but for now we'll look at just the chlorine. So now we want to know, how do I get that copper chloride to equal 6 also? So if I have a 2 here, that means I need to multiply all of this by 3. So that gives me 6 chlorine. So now my chlorine are equal. And now I have 3 copper. So my copper are not equal now. 3 and a 1, and my aluminum is a 1 and a 2. It's kind of nice because they're both just individual atoms, so you can multiply them by whatever you need to. So to get my aluminum to equal a 2, I'm just going to do 1 times 2. So now these are both equal. My copper I needed to equal a 3. 3 times 1 is going to give us 3. And now they're all equal. So that's one way to balance a single replacement. If we were to look at a double replacement here, this is where everybody switches places. You can also write the numbers underneath. So like 1 barium, 1 barium. I've got 2 chloride here and 1 chloride. So if I want to, I can start with the chloride. So okay, if I put a 2 on the outside here, now I have 2 chloride, and I'm going to have 2 hydrogen here, 2 hydrogen here. So those are equal now also. I've got 1 sulfate, or 1 sulfur and 4 oxygen. 1 sulfate, or 1 sulfur and 4 oxygen. So now all my other numbers are balanced. You can check the colors: green, 2 and 2, blue, 1 and 1, sulfur, 1 and 4, 1 and 4 for sulfur and oxygen. So since everything else is balanced, all I need to do is go and add a 1, and a 1. And this one again is double replacement. Let's go ahead and take a look at combustion really quick. So in the combustion reaction, sometimes they're a little bit different. We have 2 carbon and 1 carbon. Okay, so right out the gate, those are not equal. I like to save the oxygen for last because it gets a little tricky. So 2 and 1, if I put a 2 in front of this carbon, now I have 2 and my green match. And then that's going to make me have 4 oxygen on carbon dioxide. Hydrogen, I have 6 and I have 2. I want those to be equal. So I need to multiply that by a 3. So if I multiply that by 3, now I have 6 hydrogen. So my yellows are equal, my greens are equal. But now we look at the oxygens. So here I have 2 oxygen on my reactants. I've got 4 plus 3. So I have a total of 7. So we want to know now what times this 2 oxygen is going to give me 7 like my products have. Since it's an odd and even, if you were to try and solve for a question mark here, divide by 2, you come out with 7 halves. Now you can either put 7 halves or you can put 3.5, the same thing. So if you put a decimal place here, 3.5, and since these are balanced, this will just be a 1. We can't have a decimal in our answer. So we need to multiply everything by 2. Since it's over 2, the only way to cancel that is to multiply the entire thing by 2. So if I multiply this whole thing by 2 now, so my parentheses here, if I multiply everything by 2, because you can't just multiply one thing by 2. That wouldn't work. So now I have my 1 turns into a 2. My 3.5 turns into a 7. My 2 turns into a 4. And then my 3 turns into a 6. And if you go back and you're like, okay, now let's check out our RAP chart and see if everything's balanced. All my numbers add up to be balanced on both sides of the arrow. So if we're looking at that, we have our reactants, our atoms, and our products. We have carbon, hydrogen, and oxygen. So on my reactant side,